So in this section, I want to talk about the electrical, it's called the electrical power. And so basically, if we look at this, so if you just look at this circuit here, so this is circuit. And this has some, that's my body. So the body is always going to supply delta V. So remember that delta V and so basically the point is that at any point in time, what this body is going to do is that it's just moving electrons around. So if you think about it, so electrons are moving around like that continuously. So let's say that at any point we have some amount of charge that is moving, that is Q. Then I can calculate how much amount of energy is given to that charge by using this equation here. If you remember, we said that charge times the V is energy, right? And so if you want to calculate the power, basically you just take the derivative of that of the energy with respect to time. And because this voltage is a constant voltage, it's not changing, so when you take the derivative here, you can pull this out of the derivative and then you just multiply by the Q by dt. And the Q by dt is a current. And so I can say that the electrical power is given by this. So here, now how to move from this equation to this equation here? I know that resistance is given by delta V over I. And so it means that I can substitute this equation here and get this equation as power. All right, so let me stop share, and then I want to share this on the screen here. So I want to talk a little bit more about this. All right, so basically, I think the equation that you guys need to remember is this equation right here. So electrical power is equals to current times voltage. So we're going to call this equation number 1. And so again, this is my circuit right here. So we have some power supply that is supplying some delta V. And this is connected to a resistor. So this is a resistor. Now this resistor has the value R and the voltage here. So whenever you connect a power supply, so when you connect this body to my resistor, then there is a current. And the current that is going to flow, I can calculate this current because I know that resistance is equal to delta V over I. So this is the equation that tells me how to calculate the current. Right? So generally, we take these two equations here. And you can always combine these two equations together. All right. So as an example, I can say that from equation number 2, let's write delta V as I times R. Then if I take delta V equals to I times R and substitute into equation number 1, sorry, my power here should be I times delta V, I delta V. So if I substitute that into my equation number 1, you see that I can also write my P as P is equals to I times delta V, which is that. And so this is equals to I squared times R. So this is the second equation that you can use to calculate the power. Now we can also say that from equation number 2, so from equation number 2, let's write I as delta V over R. Then again, we're going to take this I and substitute back again into my equation number 1. And notice that with that, I can write power as let's say delta V squared. So to put everything together as a summary here, there is 3 equations for calculating power. You can calculate power as I times V, I times delta V. You can calculate power as I squared times R. Now all of these equations are the same. Delta V squared divided by R. So you could use any of those 3 equations if you have a problem, you want to calculate what the electrical power is. Now this power is going to be because this is change in energy, so change in electrical energy over change in time. So the unit here is going to be joule per second, and the joule per second is called the watt. Right. So with this, let's look at one example here. So we've just seen that electric power. So I have 3 equations. The first one is P is equals to I times delta V. The second one is P is equals to I squared times R. And the fourth one is P. The third one is P is equals to. Now you could use any of this equation. It just depends on what is given in the problem. So if the problem gives me current and voltage, I use the first equation. If it gives me current and resistance, I use the second equation. If it gives me voltage and resistance, I use the third equation. Now let's do a quick example here. So in this example, we're going to suppose that we have a power supply. In this case, my delta V is equals to, let's say, 10 volts. And we're going to connect this to a light bulb. Now this light bulb has so this is a light bulb. Now in the light bulb here, this is called the which is just a wire that has a given resistance, which in this case, let's just say the resistance is equals to 100 ohms. So this is my bulb. Now, what do we want to calculate? So part A, so calculate the current. So how much amount of current is flowing? And then part B, calculate the electrical power. So we have two parts I want to calculate. So we have this simple problem here. So we have a 10 volt battery. It's connected to a 100 ohm light bulb. I want to calculate the current. So the current is I. So when I calculate the current, I can use this equation. So resistance is equals to the V over I. And so solving this equation, I get current is equals to delta V over I. And so if you plug that into your calculator here, your delta V is equals to 10, your R is equals to 100. So that would give me a current of 0.1. And so let's see what we have. So what we know here is that we know what the current is. So current is equals to 0.1. Resistance is equals to 100 ohms. And delta V is equals to 10 volts. So I can use any of these equations to calculate power. So for example, let's use equation number 1 here. So if you want to calculate the power using equation number 1, you take the current and you multiply by the voltage. So this would just be equals to 0.1 times 10. This would give you 1. So this is 1 joule per second. So it means that in every 1 second, the light bulb is getting 1 joule of energy. Now, if you use the second equation, notice that you're still going to get the same answer. So any of those equations will give you the same result.